Hello, our amazing listeners of Neurocareers Doing the Impossible. It's your podcast host, Dr. Milena Korostenskaya, or simply Dr. K. And I'm excited to welcome you to the second season of our podcast, exploring entrepreneurial careers in neuroscience and neurotechnologies. Have you ever wondered what it takes to transform brain science into groundbreaking products and services? Are you curious about the fearless visionaries who bridge the gap between neuroscience and entrepreneurship to change people's life and reshape our world? Are you ready to explore how to navigate the uncharted waters of neurotech entrepreneurship? In season two, we're diving deep into the world of entrepreneurial ventures in neuroscience and neurotechnologies. If you are looking to create an immediate impact and translate your neuroscience and neurotech ideas into innovative services that truly make a difference in the world, this season is tailor made for you. Join us and learn from the best in the field about succeeding in the entrepreneurial journey in neuroscience and neurotechnology where innovation meets impact. We've got an incredible lineup of guests who are not only shaped their careers, but have also made a profound impact on the field. Throughout this season, we'll explore the captivating stories of visionaries who've risen to the challenge, who've turned obstacles into opportunities, and who've innovated in ways that are changing the landscape of neurocareers. So, whether you are a seasoned professional in the field, an inspiring entrepreneur, or simply curious about the intersection of science and business in this ever evolving arena, the season promises inspiration, education, and a glimpse into the exciting future of neurocareers. I am Dr. Milena Korostenskaya, the founder of the Institute of Neuroapproaches, where I help people establish successful careers in neuroscience and neurotechnologies through career coaching and education. So let's dive into the entrepreneurial journeys that are shaping the future of neuroscience and neurotechnologies together. Tune in now into the thrilling episode number 74. Dear Neurocareers podcast listeners, prepare to be inspired by a journey that combines entrepreneurship, cognitive science, and the limitless potential of neurotechnology. Our guest today is Kirill Korotaev, the co-founder and CEO of Purple Gaze, an AI-powered eye tracking platform that's set to reshape how we collect data from the brain. But Kirill's story goes beyond innovation. It's a testament to pushing boundaries and embracing challenges. Imagine stepping into the vibrant landscape of the Argentine neuroscience community and presenting your vision in a language you've secretly mastered for a month. Kirill did just that, surprising his local team members and connecting with the audience at Universidad Torcuato Di Tella on a profound level. With over 5 years of experience in management and marketing, Kirill brings a wealth of knowledge to the world of neurotechnology. He is not just the CEO, he is a global keynote speaker who believes in the transformative potential of this field to enhance our life. In this episode, we'll delve into Kirill's entrepreneurial journey, his background as a cognitive scientist, and the exciting developments happening at Purple Gaze. Join us as we explore the convergence of technology, neuroscience, and the pursuit of a brighter future. Welcome, Kirill. It's a great pleasure to have you today on our podcast. Where are you joining us from today?
Thank you very much, Milena, for this wonderful introduction. It's a pleasure to be on the show. It's a beautiful summer afternoon in the vibrant city of Buenos Aires in Argentina. As you already mentioned, at the end of the last year, I got to be a part of the Buenos Aires chapter of the Global Neurotech X Hackathon, mentoring some of the brightest minds in the Argentine neuroscience community. The energy of the hackathon was incredible, and seeing teams dive into tricky projects with such passion and under tight deadlines was super inspiring. One of the highlights, also for me personally, was seeing that several teams chose to incorporate also eye movement data into their projects. And now we are also in talks about teaming up with local universities and hospitals. So I can't wait to see what 2024 has in store.
Yes, absolutely. And I'm sure it has so much to offer, especially to those who are working in the field of neuroscience, neurotechnologies. And now that you started talking about the hackathon, I think that might be a very important conversation for those who wants to try themselves in the practical aspects of neurotechnologies. Can you talk a little bit more about the hackathon, its value, and also what are opportunities for students to join, not only students, professionals at different level to join and do things at the hackathon?
Yes, I absolutely love the spirit of hackathons, particularly this one from Neurotech X. It was held simultaneously, I think, in, if I'm not mistaken, in like 8 different locations across the world. And it also was very inclusive. So the only requirement was to have curiosity about neuroscience. There were also different tracks. So for people who want to tinker with hardware and electronics, for people who would like to work with neuroscience data, but even for those who don't have much of the technical background, there was also a neuroethics track and brainstorming designs of future neurotechnologies.
Mhm. What is the minimum requirement for the skill set that is needed to participate in the technical aspects of hackathon?
Yeah, so I think for the data track, understanding, being able to read previous publications in the field, then being able to perform statistical analysis is a big plus. People nowadays use Python or R for this, and yeah, of course, like working with GitHub and being able to read others' reads and develop on top of this open source code would be an advantage.
Mhm. So now that hackathon ended, some people who just are learning about this opportunity, they might consider participating in the next hackathon, which will happen, let's say, in a year. What would be your recommendation to prepare for a hackathon for a person who is just getting into the field of neurotechnologies?
Apart from the Neurotech X community, there is also one other awesome community that is called Neuromatch. They provide learning for both neuroscience and AI. So I think it would be great to like also try to get involved with this community. And yeah, I think Neurotech X also has some educational materials. So yeah, just delve in and immerse yourself with a lot of educational content that is available today on the internet.
Hmm. And what motivated you to participate in the hackathon?
Yeah, so we have several team members that are based here in Argentina, and they invited me to participate and contribute. And of course, I couldn't say no to such an opportunity. Also, very curious about the state of neurosciences in Argentina. After the hackathon, I'm very confident that neuroscience community in Argentina has a very bright future.
Excellent. And can you tell a little bit more about that story of learning the language to actually deliver a speech in just 1 month? So, how did you do that? How did you accomplish it?
Yes, I had a very good teacher. So first, I'm like perhaps recently became fascinated with languages in general, and I can support basic conversation in Japanese and now also in Spanish. I know a little bit of Dutch, and now I'm starting to study Portuguese. So I had a very good teacher, and I first prepared in English, and then we translated into Spanish, but using only those words that we already covered in the program.
Mhm. And your approach, I'm just very curious because this question that many people ask, yes, learning the language, is this a traditional approach when you are starting with the grammar, with the rules, or it's more immersive type of approach where you just start listening and trying to understand, trying to speak? What approach did you choose?
Yeah, I would say it's kind of mixed. It was mostly focused on conversation because yeah, I didn't have a goal to like complete any kind of certification. I just wanted to be able to communicate my needs or like yeah, have a dialogue with someone. So you still have to learn some grammar and structure, but mainly it was designed in a way that you start speaking from the very beginning. And yeah, I had an unfair advantage that I was also immersed in the Spanish speaking environment. But if you don't have such an unfair advantage, you can just immerse yourself in the content of those language. For example, yeah, listening to music or uh, watching videos or movies. I think it also can greatly help.
Yeah, thank you. And what do you think was the advantage of you delivering a speech in Spanish versus if you would deliver it in English?
Yeah, I wanted to connect with the audience on a deeper level. For me, it's like just too basic to deliver a speech in English since yeah, I consider myself pretty fluent and I've been using English in scientific and business communications for over a decade. So yeah, it was also not challenging enough, and I wanted to push myself further out of the comfort zone.
Yeah, so it definitely shows that you are looking for challenges in general, yes? And this might be one of the reasons why your first degree in, I think it was business marketing space, wasn't enough for you. Yes, you were looking for more, making a bigger contribution. So, can you tell our listeners your story? How did you get into the field of neuroscience, neurotechnologies?
Yes, so I would label my way into neuro as a reductionist path. Like the most of us, I didn't have a well-developed idea about what should I do with my life after graduating high school. And I ended up venturing on studying management and economics. And there we were taught classical economic theories based on Smithsonian assumptions that people kind of make rational decisions by default. And though I was not exceptionally smart in my early 20s, somehow these theories seemed fishy to me. And when I came across works by Daniel Kahneman and Dan Ariely on behavioral economics and cognitive biases, that further reinforced my intuition about the faultiness of classical economic theories. Spotting other biases and being more self aware is already a great progress. However, I wanted to delve deeper into how me personally and also we as humans in general can make more rational choices, which led me to back then very niche, less wrong community and getting familiar with Eliezer Yudkowsky's ideas. Looking back at those days right now, I'm honestly puzzled with how those people predicted a lot of things that are only starting to unfold today.
Can you give some examples, yes, of that?
Yes,
Mhm.
definitely. There were discussions about the potential dangers of artificial general intelligence or AGI. You know, this super intelligent entity that is like exponentially smarter than us, and the need for creating ethical committees and regulations to ensure that this AGI shares our human values, which is called the super alignment problem nowadays. And this was like when neural nets were completely useless gimmicks. If I'm not mistaken, around 5 years before two PhD students at the University of Toronto, Alex Krzyzewski and Ilya Sutskever, under the supervision of the godfather of neural networks, Geoff Hinton, published the AlexNet paper for the first time demonstrating better than humans performance in object classification problem, kickstarting the AI summer that we are still experiencing today. So after exploring behavioral economics and rationality, I learned about the field of neuroeconomics, which uses neuroimaging methods to study how people make economic decisions and searches for the neural correlates of these choices. Ultimately, even being able to predict the outcome seconds before the decision was made, which can be quite scary for the proponents of the free will concept. By the way, I'm not claiming that we don't have free will at all, but it's certainly not real time. We are becoming conscious about our choice only after the decision threshold has been reached. But this doesn't mean that we're like just watching a movie from the first person perspective. So my path evolved from classical economics to behavioral economics, then to neuroeconomics, and finally to cognitive science, and particularly the intersection of neuroscience and AI. During my master's in cognitive science, I got the opportunity to experiment with various neurotechnologies and conduct research on human visual cortex with transcranial magnetic stimulation and deep neural networks. My reductionist descent ended here, as I didn't went on to become a molecular biologist or a quantum physicist. And I also decided not to pursue the PhD and transition to the industry instead, since from the very beginning of my romance with neuro and AI, I wanted to make a bold positive impact in the real world. And unfortunately, the academia is just not perfectly wired for it.
Mhm. And so, how did you get into the field of eye tracking? You were fascinated with the brain, with the cognitive phenomena, with decision making. How is it related to eye tracking?
Yeah, so my former supervisor and the head of the vision modeling lab, where I used to work as a research assistant, was Joe McInnes, Canadian expert in vision neuroscience and AI. And eye tracking was his favorite research instrument. So after I graduated from my master's in 2018, we kept in touch and started having conversations about eye tracking technology. I remember how Joe told me, hey, Kirill, this bulky equipment that we're using in the lab, it costs like a luxury car and it has a daunting learning curve. And inspired by the tremendous progress in AI and especially in computer vision over the last few years, we had a breakthrough idea to merge these two parallel worlds. Eye tracking technology stagnated for like 15 years, and we realized that if we harness modern computer vision and image processing techniques, we could revolutionize eye tracking, make it much more accessible and easy to use, which in turn would unlock new applications and create whole new industries.
Maybe for those of our listeners who are not very familiar with the field, can you just give a brief introduction into eye tracking? Why do we need it? What is it first of all? Why do we need it, and where can we apply it?
Yeah, sure. So basically, like our eyes are observable extension of the brain. Therefore, by precisely following where the person is looking and the dynamics of the changes of his pupil size, we are able to obtain deep insights on cognitive processes such as visual attention, working memory, cognitive loads, and mind wandering, etc. And apart from it, what also we at Purple Gaze are particularly excited about is that abnormal eye movement patterns are like footprints that are left behind by brain disorders. So this technology also enables more objective and patient-friendly assessments of many neurological and psychiatric disorders, including mild cognitive impairment, autism spectrum disorder, and schizophrenia.
Yes, very interesting. So, you said that the field has been stagnant for a while. What is the difference between the approach you are providing and the approach that has been used until now?
Yes, definitely. So basically, like camera-based eye tracking has been there since the 60s. However, surprisingly, there were not a lot of innovations since that era. So yeah, before Purple Gaze has entered the scene, eye tracking market has been very polarized. So on the one hand, there were like cost-effective systems that could cost as low as $100, and they are limited to fixation data, which is not a big deal if you only want to know where the person is looking, and it works well for applications in marketing, UX, and gaming, for example. So these systems are pretty easy to set up, but totally incapable of providing deep insights into human cognition. On the other hand, there were prohibitively expensive systems priced up to 60,000 US, which are like really bulky and hard to operate machines designed for more demanding applications such as neuroscience and clinical research. Those systems often require multiple computers for data processing and experiment display. And our vision for FOXIE was to bridge this gap and create the best eye movements research tool out there that would combine the ease of use and portability of these low end systems with the data quality and depth of high end systems. We firmly believe that meaningful innovation is always rooted in research, and none of the existing tools met our high standards. So we set out on a journey to build the ultimate research tool that we would be excited to use ourselves.
Yes, so you decided to implement computer vision, AI technologies into this type of eye tracking system. So, how does this implementation help you innovate the system and make it possible to do this amazing type of research?
Yes, as I mentioned, our flagship product is called FOXIE. It is a first portable eye tracking computer that captures more than 600 high quality gaze samples per second, enabling deep insights on cognitive processes and the state of the brain health. Yeah, and FOXIE is a reliable companion that is designed to support groundbreaking research in experimental psychology, neuroscience, and vision. And it's already making waves at leading research university labs across Europe, North America, and Asia. And now we are also expanding to Latin America. Apart from the technology itself, we have a very unique approach to customers that also stems from our expertise in the field. We are particularly aware that pretty much every lab has their own custom pipeline for experiment design, data collection, and analysis. And therefore, instead of trying to provide a one fits all solution, how anyone else is doing, we are offering researchers flexibility to select the building blocks for the experiment. Our Purple Gaze Lab software is complemented by what we call an experiment design kit or EDK, which is a suite of Python libraries we developed for building custom experiments. And additionally, we've curated an experiments gallery showcasing templates of popular neuroscience experiments to spark creativity in how our EDK can be utilized. We have also developed a highly customizable dashboard that automatically generates visualization post data collection, including gaze paths, heat maps, and pupil size variability plots. And we're also, thanks to AI, able to automatically extract eye movement features such as blinks, fixations, and saccades to streamline the data analysis process.
Yeah. Can you provide maybe some studies that were performed with the traditional systems versus the studies that are performed with your system, just to show what the system enables, what are options that were not available before that now are available when using your system in real experiments?
Yeah, so we have just recently launched last year. So We don't have the results of such studies yet, but they are in progress. And once these data becomes available, I would be happy to update you on the status.
Thank you. Why purple gaze? Why this name that you chose?
Yeah, so my co-founder Dmitry is an expert in high performance computing and an ex NVIDIA engineer. And when we were brainstorming the name for our future enterprise, we've figured out that we are both fond of Jimi Hendrix. And actually, the name of our product, FOXIE, is another reference to one of his songs.
Very interesting. Very interesting. Now, we already learned about how you came into neuroscience, neurotechnologies in general, and about your product. Now, let's fill that gap between you finishing university and developing the product. How did it all start? What helped you to get on this path of developing your own product? Maybe can you guide us through that journey?
Yes, definitely. Yeah, we also had a bit of unfair advantage in terms that our scientific advisor, John McInnes, he was also himself a representative of our target audience. So he was a researcher who frequently uses who uses a tracking in his daily routine. So because of that, we already had some insights. However, we didn't stop there, and we decided to also conduct interviews with hundreds of other eye tracking researchers to validate or to find out that some of our initial assumptions were not that generalizable, maybe for a wider audience. But basically, there are like two very different ways of thinking in academia and in industry. So yeah, it was like a very gradual process to start being able to think differently. So in academia, you do like literature reviews and meticulously learn about everything that was ever published in your field for like several months or years before start actually like taking any action. In startups, it's vice versa. You just start doing something and you learn by mistakes, and you learn from your mistakes and adjust along the way. But we're not like typical startup, we're a neuroscience startup, so we kind of had to combine to make a hybrid process of these two. So basically we're still doing research, we're staying on top of science, so in our field. It's just that like our threshold for making the decision is lower, so we need to make decisions using less data points than if it was a standard university process, and yeah, then also adjust accordingly.
hmm Absolutely. How long did it take for you to switch to that different mentality from academic to more industry oriented? And what was the biggest challenge of doing that for you?
Yeah, I think like once you learn to think like a scientist, there is like no coming back. So you can't completely transition from this viewpoint, but I wouldn't think of it as a disadvantage. But I think like usually when I got only masters in cognitive science, I didn't went on to have a PhD. So this also I think helped me to adjust faster, because I believe if I have spent way more time in academia, maybe this transition would be harder. But yeah, I think like we've been a part of several startup accelerators. For example, like Health Week program in Amsterdam, which is a joint venture by Startup Bootcamp and Amsterdam Technology Institute. And yeah, then we also recently graduated from the Rockstart Emerging Tech program. And so, yeah, these accelerators also can help with shaping your mind into more like business versus science oriented.
Definitely. And speaking about accelerators, what do you think was the biggest help that they provided you with developing your startup?
Yeah, apart from funding, I think mostly they give you another perspective. From my experience, I think it's the most important part.
Mhm. So, at what stage of the startup developing are you at the moment?
We have our Center of Operations and Neuroscience Lab in the charming medieval town of Utrecht in the Netherlands. And last year, we've partnered with NVIDIA through their Inception program for startups, received investment from the Rockstart Immersion Tech Fund, and we are also honored as the best startup in computer vision category by the Netherlands AI Coalition. Right now, we have a cross-disciplinary team of 10 stellar individuals split into 4 different working groups. Our neuroscience team or experiments team, how we're calling it internally, builds tools for researchers, simplifying experiment design and data analysis. Apart from that, they're looking for abnormal eye movement patterns that signal of brain-related disorders. Our algorithms team's objective is to guarantee that our eye tracking algorithms can accurately capture even the fastest and tiniest eye movements possible. And our hardware team builds the base that enables both our algorithms and applications to perform at their maximum capacity. And finally, we have our community team that is the glue that keeps our team aligned and bridges our vision with the world. Yeah, at the moment we are already working on the next generation of our FOXIE systems that will become the next state of the art in both data quality and usability. And we are going to reveal and launch it very soon.
Mhm. Very interesting. Thank you. And speaking about your knowledge, your experience with AI. You said that you got an award in the Netherlands for your advanced use application of AIs in technology. How do you stay up to date on this newest developments in the field?
When I was just starting to learn about the existence of neural nets, like maybe 2013, there were not many resources available, to be honest. And the learning curve was very high. So you had to manually learn like every step of building your neural network. There was not available models, there were not no available data sets, there were no like online courses or anything like that. I think today it's like dramatically changed, and perhaps you can even not know how to do some basic coding but still being able to work with the with learning models. So I think there are tons of materials available. To name a few, there is Deep Learning Institute from Andrew In, one of the founders of Coursera. Yeah, then there are several newsletters that you can sign up for. There are like tons of material on YouTube. I personally like watching like paper reviews. For example, there is a guy called Yannick Kilcher. Yeah, he does awesome explanations and he is also very fast. So like once some new model is released, and now it like happens almost every day. So he would record a video on it and really dive deeper into explaining how it works, or if it's not open source and if we don't know much about how it actually works, he would also like provide some insights on what is behind this black box.
Yeah, that is so helpful. I will definitely ask you to provide those resources for our listeners. I will add them into our podcast notes. So those who want to study and to get more in depth can do that. You also mentioned a team that you've already built quite a big team of people. They work at different locations and do different contributions. So, what did it take for you to build such a big team already to this date? How did you do that? And what are the most important qualities that you are looking in your team members?
Yeah, so I think it's not very wise to look for talent given the objectives that you need to perform in the short term. In the long run, it would be much more advantageous if you maybe bring in a person that maybe do not yet have a domain knowledge in some particular aspect of programming, for example, for the next groundbreaking tool that you want to launch. But if he or she is a fast learner in the long run, you would be much better off.
And how are you finding people that are joining you from different locations, different parts of the world?
I think, yeah, it's a good idea to tap into some of the communities. We were able to bring some decent talent from Neurotech X network. Yeah, we believe that great talent can be anywhere in the world. So, yeah, we don't discourage anyone to apply for our openings. You have to kind of look everywhere yeah, tap into several communities about people who are excited about neuroscience and people who are excited like about startups and working in the startup in general because it's also kind of different profile. For example, people who will want to work at the big corporations like Google and Meta perhaps would be better off going to work there, and not for us because it's yeah completely different environment. So we are also more looking for people who can stand the like constant uncertainty and rapid change of plans, who value having like more agency, for example. It's a great thing about having a cross-disciplinary team with people from a lot of different backgrounds who could also introduce ideas from different fields. We even have a rocket scientist in in our team. They're amazing talent everywhere, and tap into some communities of enthusiasts is one way to hire people, and of course there is also an element of luck.
Absolutely. And what would be your recommendations for those who actually are interested and want to apply to work with you and do things in your company?
We are constantly on the hunt for the best talents across the globe. So don't hesitate to apply. We have a careers page. I think it's then you can't you can see it from the main page. But if you type purplegaze.io/careers, then you would see it and you can apply through our website. We are currently looking to fill positions related to both hardware, software, research, and we also have some non-technical positions like content marketing professionals, and we have internships as well.
Yes, and it's a time I think to apply for internships right now, usually for the summer. That's good to know for our listeners. And let's look now a little bit into the future. Yes, we talked about the past, how you got into the field where you are right now. And let's talk about some future and possible applications of eye tracking technologies. I'm very curious about people with locked in syndrome, let's say with ALS. We know that eye tracking system is actually very helpful until a certain point when people are still able to to move their eyes. And then there is a point when that's already become not possible. Is there any possibility with your innovation in the technology to prolong the use of eye tracker? Maybe it's more sensitive to very tiny eye movements that are still present. So I just want to look at the problem through this lens, what your technology can potentially provide, maybe.
Yeah, very interesting question. Yeah, with such deliberating conditions, of course. Yeah, if we compare, for example, like eye tracking and EEG that is also used for locked-in patients to type text, for example, or to communicate and express their basic needs. Currently, eye tracking is faster and takes less time to being able to learn how to perform this task. So it has a lower learning curve. It works better currently for the like eye tracking based speller is faster than BCI based speller. However, in the conditions such as ALS, which progress over time, and when the patient is already not able to use eye tracking based assistive communication device, in that case, I think instead of trying to accommodate for like tiny eye movements that they're still able to make, I think it's just better for this patient to transition to the BCI based approach.
Yeah. Okay, thank you. Where else do you see the future application of systems like you are developing, where maybe conventional systems are not as good or do not provide this sensitivity or options available?
Yes, I was trying to explain that the conventional systems are either they have good data quality, but they're hard to use, or they have poor data quality and they're easy to use. So I think like being able to bridge this gap would unlock also many applications like in clinics or hospital environment. I think it has been the main bottleneck that medical experts they don't have time to learn how to operate with the new technologies. But if there is really easy to use system that doesn't have a high learning curve, then they would just like need to press a button to start recording, and like in 5 minutes they will have an automatically generated report about the state of the person's brain health. I think that would facilitate the adoption of eye tracking in this field.
Definitely, definitely. And speaking about those innovations and differences from existing systems, in one of your interview, you mentioned that your system is using embedded system design. Yes, so one of the components that differentiates it from others. Can you maybe provide just a brief overview for those people who are not familiar with embedded system? What is that, and then how does it help your technology to provide solutions that current systems do not provide?
So yeah, I was briefly mentioning that due to some computational requirements, the current systems that are used for neuroscience and clinical research are using multiple computers. So they like literally will sell you an eye tracker together with the computer that does data processing, and you connect the eye tracker to another computer, which is like where you would show experiments to the participants. And yeah, this also leads to overcomplicates the setup and also leads to network latency delays because all these computers need to talk with each other. So our checker is a computer itself. You need a one computer where you connect our system by via USB, and all the data processing we do on the device itself. All our models are deployed on the device itself, so it's more secure and also makes us more scalable because there are no hard requirements to the researcher's machine. So it would work equally well with old cramped PC and the most novel one.
Mhm. What are the studies from the past that were done with eye tracking systems that fascinated you? Maybe you were the most impressed by those studies, which you would like to be repeated with your new system to provide maybe more insights into the phenomena.
Oh yeah, too much interesting studies. Very hard to choose my favorites. There were interesting studies on autism spectrum disorder, for example, where the researchers would show some images, show to the participants some images of faces, that could also depict some certain emotion. And yeah, there was actually one recent study, I think the University of Minnesota, where they did this emotion recognition task. So yeah, they were showing emotional stimuli with faces depicting several emotions. And the task was to identify which emotion has been depicted on the face. And the interesting finding was that basically there were no significant differences between patients with autism spectrum disorder and unaffected participants on the accuracy of identifying the particular emotion. However, there were significant differences in both eye movements. So patients on the autistic spectrum tend not to be that interested in exploring facial features, and sometimes they also like avoid others' gaze or like avoid looking into other person's eyes, for example. So yeah, there were like significant differences in how they were viewing those images and in reaction times.
Yeah, so how do you think your system would be able to benefit this type of study? What insights would potentially become possible with using purple eye gaze?
I think like mm, what we're enabling with Purple Gaze is that not only highly trained professionals could conduct these experiments in the academia environment, but also we can enable the collection of high quality eye movements data at scale, yeah, for the first time in history. And that could be collected by non-professionals such as nurses or GPs, for example. Yeah, that would be like not for research purposes, but for already for real world assessments and monitoring of neurological and psychiatric conditions.
Yes, and I'm very curious about that. In order to use this in clinic, we should have at least already some biomarkers, or at least potential candidates into biomarkers. Yes, when using eye tracking systems. What are those potential biomarkers that currently are already accepted for certain disorders?
There are like more than 20 different disorders that historically found some correlations between eye movement patterns and the disorder itself. So, talking about biomarkers, we need to distinguish certain trade off, which is about being able to explain, to understand more, like why this particular phenomenon is happening, and being able to accurately detect it, but not necessarily learn about the etiology. So there are two approaches. In the first approach, you like just manually kind of also, for example, using previous studies, you understand what aspects of eye movements, like for autism, maybe like, for example, when where fixations were happening, how many of these fixations were there. For schizophrenia, for example, you can show some slowly moving stimuli, tennis ball, and ask the participant to look at to follow the path of this ball. And like, yeah, you would see that in the case of unaffected participants, they can almost perfectly repeat this path of the ball with their eye movements. And this is not the case for the schizophrenia patients. There would you have see the gaps on the ball trace. So these are the cases when you already like have some hypothesis at how to design your experiment and what kind of eye movement features you are going to look for. Another approach is machine learning based, where you, yeah, typically would just collect data during the free viewing task. So particular instructions from the experimenters to follow something or to perform particular task. Then you would just having a ground truth data of the patient population. You would just do the regression basically and split the group and see like what's. But yeah, so this approach can have a high accuracy, but hard to make an interpretation what exactly is driving the difference, what kind of eye movement features are correlate with the disorder here.
Yeah, yeah. So of course they first need to be established, but maybe exactly with your new approaches that allows for machine learning, extracting certain features from the data, it will help to establish those biomarkers in the first place. Yeah, so that's one possibility. And of course, also for clinical use, do you need necessarily to have a medical grade device, or that's not an absolute requirement? How does it usually work?
Unfortunately, it's an absolute requirement. At least like when you comply with FDA or MDR requirements, you have a pretty high probability that your system is safe. This is a positive part, but of course there are a lot of regulations, and it's pretty hard to comply with them all. This is why at the moment we are not providing our system for the medical use, but instead we are working with the researchers, and some of them are clinical researchers who do research on neurological disorders. Yeah, making our system easy to use and preparing for these regulatory hurdles.
Yeah, absolutely. And it's doable. You know, the most important that you already have that in mind and you want to apply it in the future. You will develop steps towards that, which is wonderful. And of course, I wish you all possible success with that. And just to bring our conversation to that point of the connection between eye tracking, eye gaze, yes, fixation with the cognitive function, how can we infer from the eye tracking about the cognitive status of the person? What inferences can we make based on the information we collect with the eye tracking system?
There are many types of eye movements. Some of the fundamental aspects that I've already mentioned are fixation and saccades. So imagine yourself at the theatrical performance. However, unfortunately, you didn't get the best seats, and therefore you have to use binoculars. So when you're observing a particular actor through binoculars, you're making a fixation. And fixations occur when we direct our gaze to an object, aligning it with the fovea, the retina's high resolution center. But then you decided to shift your focus to observe a different actor, perhaps, or maybe some interesting guests at the royal box. And when you're making this attentional shift, you're performing a saccades. You're performing saccades, which are rapid eye movements that happen from that take from 20 to 100 milliseconds, and they are transitions between points of interest. So transitions between fixations. Our eyes are pretty simple machinery, but our brain is incredibly complex. So, for example, our visual system cleverly masks our eyes' blind spots, areas like in photoreceptors due to the optic tract's exit point. And despite these blind spots, our vision appears perfectly complete and uninterrupted. So, how is this possible? This is because our eyes constantly perform these rapid saccadic eye movements, stitching together a coherent picture, like a skilled editor assembles fragmented film scenes into a seamless movie. Another example is reading experiments that are also frequently used in psychology and neuroscience research. So during reading, we make eye movements each quarter of a second, which means that in order to really understand participant reading behavior, you need to capture these saccadic eye movements with like at least 500 hertz sampling frequency. So this is also why it's important to not only collect eye tracking data with high spatial resolution, but also with high temporal resolution. Around 60% of the brain is involved in vision, and eye tracking is a tool that can provide insights about the visual system.
Mhm. What was the most interesting thing you learned about the human brain, about cognition, while working in this field, in creating eye tracking system and testing it and learning about it?
It's very hard to choose only one thing because there is like too much information that you could infer from the eye movements data. First, like eye movements themselves are in kind of vacuum. They don't have much value. So it's important that you make this connection between where the person was actually looking and what was happening on the computer screen at this moment, and what kind of eye movements the person made. The magic happens when you like combine two of these sources of information. Not only like where the person was looking, but for example, also the dynamics of the changes of the pupil size is an also important characteristic. So, like for example, when we have more cognitive, when I'm performing some demanding tasks, the pupils tend to dilate more, and same thing also happens when the person is excited about something. So if we would just see the like people size dynamics and we wouldn't know what was happening in this moment, we could make completely wrong assumptions. So this is why I think it's like yeah, always important to look both at eye movements, but don't forget also about what was actually going on at this moment.
Yeah, so the context itself.
Yes.
So, what, in your opinion, is the biggest mistake people are making when working with the eye gaze systems?
I think for the researchers who are just starting to tap into eye movements data, yeah. So one of our team members told me about this anecdote that one researcher was working with eye tracking, and it was the study also incorporated psychedelics. So some people were also one of the group. So experimental group was under the influence of psilocybin. So after the researcher conducted this experiment on like 20 participants, they found out that the data was blank. So yeah, you don't need to analyze the data after each participants, but at least you have to check for validity. And so with our automatic data dashboard would appear afterward, straight afterwards. You complete the experiment, and we would avoid this situation.
Yeah, that's very important feature. I'm so glad you integrated it. So that's a big bonus, I think, to your system. Wonderful. So for those who want to get into the field, eye tracking, working on the experiments, maybe finding possible biomarkers for the disorders. So what is your recommendation? Where should they start?
Yeah, plenty of resources are available nowadays. Of course, you can get a degree in neurosciences or cognitive science or other adjacent fields, but I think it's only a requirement, perhaps, if you would want to continue on an academic path. And yeah, I know, for example, that Elon Musk at Neuralink, when he is looking for the best engineers, he's not requiring them to have a domain knowledge in neuroscience. So when you have a cross-disciplinary team, like neuroscientists can learn from programmers, programmers can learn from neuroscientists, and so on. So yeah, I think like don't be discouraged if you like feel that you don't have a lot of knowledge in this field. Maybe perhaps if you don't have domain knowledge in this field, you have knowledge of some other field that could reinforce the neuroscience. And tried and hackathons, several events in your area, lectures by professors, whatever, participate in experiments at your as a participant at your university. Researchers always love to tell you everything about their experiments. So and they even would pay you for your time. So yeah, I think it's also one of the great sources to learn about the field.
That's great. How do you see the future of this technology, of eye tracking technology, in the ideal world? What would be the next big thing in the development of eye tracking systems?
I think once it's already like super easy to use and when we can seamlessly collect data and perhaps also like not only in the lab but in also in the real world. What comes next is multimodal data. So basically, also combining several neurotechnologies together to get even more insights. So of course, I'm not preaching like that. Eye movements data is like yeah, panacea from everything, and is the only thing you should do. No, it's a very cool source of information and more objective than many others. But it's not the solution to every problem in the world. But by combining different modalities by recording simultaneously eye movements data and with EEG or with MRI, you can get even more insights. And I think the future definitely lies in the. So we first we make those technologies accessible and easy to use, so more people can use them, and then we combine them together in an ecosystem that provides even more value into the world.
Do you see a future where there is a combination between brain-computer interfaces and eye tracking systems, and what can be potential advantages of this combination?
As you already mentioned, for in the case of ALS patient, it makes sense to first use eye tracking and then EEG, and maybe this system also can automatically adjust based on the progression. But yeah, it's only one example. A lot of fun interactive applications are also could take place for the for the patients as well, but also for general audience. Yeah, so we also have one of our side project about like composing music using your eyes. I don't know if we also combine it with EEG maybe then and add an AI on top. There would be some personalized suggestions that would end up in an awesome symphony.
Yeah. You after this conversation, you might have people contacting you to create this system of BCI and
I'm looking forward to it.
wonderful. So, in this case, what's the best way to contact you, and where can our listeners find information about your Purple Gaze eye tracking system?
You can connect with me on LinkedIn, then also follow Purple Gaze on social media. We are active on both Twitter and LinkedIn, and starting also double down on some video content. So also follow our page on YouTube.
Excellent. Thank you so much. And as we're ending our podcast, would you like to say anything to our listeners? Any advice you would like to provide, or just any final notes?
Yeah, just don't be like driven by fear that you're not good enough. And I didn't have any background in biology, and I got into the cognitive science and neurotech. So if I could do this, you could do this too.
Thank you. Thank you so much. That's great advice. And of course, Kirill, I wish all and you and all your team all possible success. And we'll be looking forward to the new developments with your system. So thank you very much for being such a wonderful guest on our podcast.
Thank you very much, Miliana. It's been a pleasure.
Dear Neurocareers podcast listeners, thank you for joining us on this incredible journey into the entrepreneurial world of neuroscience and neurotechnologies. I hope you've been inspired by the stories of those who are turning groundbreaking ideas into impactful realities. If you are looking for more guidance on succeeding in neurocareers, book a free consultation with me, your podcast host, Dr. K, at the Institute of Neuroapproaches. So, what are you waiting for? Let's navigate the path to success in the world of neurocareers and make the impossible possible together.